So in these questions you will be expected to carry out calculations that get you to work out what the theoretical yield from a balanced equation would be. There is a requirement to work with the balanced equations. They will already be balanced for you, but you need to get good at being able to work with the ratios, and we'll start by looking at straightforward ones with a 1-to-1 ratio and then get a bit more complex. When you do these calculations, you need to remember your number of moles is your mass divided by the MR. And in these questions, you will be given the MR of the reactants and products that you're expected to work with. So in this example, we have a mass of, what mass of calcium oxide would be obtained by heating 25 grams of limestone. So we have our balanced equation here. Now we're only interested in the calcium carbonate making the calcium oxide. We're not interested in the carbon dioxide, so we can ignore it. Now we can see there's a ratio of 1-to-1 here. 1-to-1. So 1 mole makes 1 mole, and that's what we need to think about. So we have 25 grams of calcium carbonate, sorry. So the number of moles is the mass over the MR. So the number of moles is 25 divided by 100. So the number of moles is 0.25. Now in this equation, 1 mole makes 1 mole, so 2.25 will make 0.25. So we need to look at the mass that would be achieved then, looking at this ratio. So looking at the mass of calcium oxide that would be achieved would be mass is number of moles times MR. So the mass would be 0.25, because that's the number of moles that we get. That's the number of moles we have, and it's working on a 1-to-1 or a 0.25 to 0.25 ratio, times the MR, this time of the calcium oxide, which is 56. So we have 0.25 times 50 equals 14. And that's the answer. Next one. Calculate the maximum mass of aspirin that could be made from 2 grams of salicylic acid. So there's our aspirin, so 1 mole of aspirin and 1 mole of the salicylic acid. We can ignore the other 2 compounds in this reaction. We know that we have 2 grams of salicylic acid, so the number of moles is the mass over the MR. So the number of moles is the 2 over the 138. .0144. So you can see it's a much longer number, but I've just shown it to those. Put the 9 in actually to that number of figures, but keep this number in your calculator because it'll be important for when you get to the next step. Now it's a 1-to-1 ratio, so 0.1 mole makes 1 mole, but 0.01449 moles would make 0.01449 moles. So the mass of the aspirin then would be the number of moles times the MR. So if we put the 0.01449 times the mass of the aspirin, which is 180, so I'll times this by 180, gives me 2.608, so 2.61 grams would be the theoretical yield we would expect for this calculation. So the next one will be still working here with a 1-to-1 ratio. So what mass of sodium chloride will be formed when 4 grams of sodium hydroxide reacts with an excess of hydrochloric acid. So we have our MRs here. So we are interested in the mass of sodium chloride due to the reaction with sodium hydroxide. We can ignore the acid and we can ignore the water. You see that it's a 1-to-1 ratio, so we keep referring back to that. So the number of moles of sodium hydroxide, we have 4, and 1 mole would be 40, so we have 0.1 moles higher. One mole makes 1 mole, so 0.1 mole makes 0.1 moles. So the mass of sodium chloride that we would get would be 5.85. And there's your answer. Okay, moving on to the next one then. So what mass of magnesium chloride? So here's our magnesium chloride. We formed when 12 grams of magnesium are reacted with an excess of hydrochloric acid. Ignore and ignore. So it's a 1-to-1 ratio. So we have 12 grams of magnesium, so the number of moles, so it's 12 over 24. So that's half a mole. 1 mole makes 1 mole, half a mole would make half a mole. So the mass will be the number of moles times the MR. So it's 0.5 times the magnesium chloride, which is 95. .5 grams. Next one. What mass of potassium hydroxide will be formed when hydrochloric acid is neutralized by 5.6 grams of potassium hydroxide? So potassium chloride and the potassium hydroxide. We can ignore those other two. Again, it is a 1-to-1 ratio, so the number of moles is the mass over the MR. So we have 5.6 grams of potassium hydroxide. 0.1 moles. So 1 mole makes 1 mole, 0.1 makes 0.1 moles, and so on. So the mass would be the number of moles times the MR. So we have 0.1 moles times the 74.5, which is going to be 7.45 grams. Okay, now those were 1-to-1 ratios. I think the next one we move on to a slightly more complex ratio. No, we don't. But we're getting there. What mass of carbon dioxide will be produced from the thermal decomposition of 173.75 grams of copper carbonate? So here's our copper carbonate, and here's our copper oxide, and here's our carbon dioxide. So we were interested in the mass of carbon dioxide, so we could ignore the copper oxide. It's 1 mole to 1 mole. The number of moles of copper oxide will be the mass divided by the MR. So the number of moles is 173.75 grams over the 173.75. So basically we have 1 mole. And then 1 mole of carbon dioxide is 44. So in this equation, in this equation, the mass will be 1 mole times the 44, which means we would get 44 grams which is 1 mole of carbon dioxide, because 1 mole makes 1 mole. The next one, what mass of calcium sulfate is formed when 25 grams of calcium carbonate neutralizes sulfuric acid? So we're interested in the calcium sulfate. When the calcium carbonate reacts with the sulfuric acid, we don't need to know about any of the rest, it's only these two. So it's a 1 to 1 ratio again. Number of moles is the mass, which is 25, over the MR, which is 100. So we have 0.25 moles of calcium. Sorry, that's a bit wrong, because you've been given calcium carbonate here, not calcium sulfate. Sorry, it is right, ignore me. So number of moles is 0.025 of CaCO3. Okay, that is correct. We want to know how much of this calcium sulfate is actually produced from this chemical reaction. So 1 mole makes 1 mole, 0.25 moles makes 0.25 moles. So the mass is the number of moles times the MR. So the mass will be the 0.25 moles that we expect times the MR, which is 136. So it's 34 grams. What mass of zinc chloride will be formed from 260 grams of zinc powder when it reacts with an excess of chlorine gas? So here's our zinc chloride, and here's our zinc powder. The chlorine is in excess, we can ignore it. So it's a 1 to 1 ratio, zinc to zinc chloride. So the mass of zinc powder we had, number of moles will be the mass over the MR. So we'll have our 260 over the 65 that the zinc is, or the AR of zinc, which is 4 moles. So the mass will be the number of moles times the MR. So we have our 4 moles times the MR of zinc chloride, which is 136. Which gives us 544 grams. And that's that one. Then moving on to, I think this time, slightly more complicated ratio. No, still the easy ones. What mass of copper will form from 108 grams of magnesium when it displaces copper from an excess of copper oxide? So here's our copper, and here's our copper oxide. Oh, sorry, these are magnesium, so it's the magnesium and the copper that we're interested in here, so we can ignore the copper oxide and the magnesium oxide. So we have 108 grams of magnesium, so the number of moles is the mass over the MR. So we have the 108 over the 24. Which is our 4.5 moles. So the mass, the number of moles times the MR. So 4.5 moles times the MR of copper, which is, or the AR of copper, which is 63.5. Which is 285.75 grams. What mass of sodium hydroxide is produced from 95 grams of sodium when it reacts in an excess of water? So here's our sodium hydroxide and here's our sodium. We can ignore these two. It's a 1 to 1 ratio again. So the number of moles is the mass over the MR. It's 92 grams of sodium. 4 moles because 1 makes 1. So mass, so the 4 times the 40. She's 160 grams. Okay, so that was looking at questions that had a 1-to-1 ratio. So we'll stop now and then do the different ratios.